Hello, algebra students. Mr. Lawrence here with another flipped lesson. Today we're going to learn a method for solving systems called elimination. Now I've got to warn you, at first elimination is going to look like it's easier, and in some ways it is. The problem is, when I was a kid, I used to love elimination. It's the way I did all my problems. I did substitution when I had to, but I did elimination a lot. And a lot of times I made a lot of silly mistakes because it sometimes has an extra step or two. Be careful with elimination. It looks easier, but it's kind of like a trap. All right. Now let's take a look at this first system here. You notice that these coefficients right here on y, I've got a plus 3y and a minus 3y. Those are inverses of each other, right? Additive inverses. What I can do is I can add these equations together. And watch what will happen. I'm going to get 6x. These are going to cancel, and I'm going to equal 18. All right? Well, 6x equals 18. I have one equation with one variable. I can go ahead and divide by 6. Hold on, I've got to go turn some fish over. Okay, the fish is turned over, and so I can get back to my math. And so I'm going to divide by 6 on both sides. I'm going to get x equals 3. And that looks pretty simple, doesn't it? Now don't forget to solve for y. I think I'm going to plug it into the first equation. So I'm going to get 2 times 3 plus 3y equals 10. And so I'm going to get 6 plus 3y equals 10. Okay. Now I'm going to subtract 6 from both sides. And I'm going to get 3y equals 4. Divide by 3. So y is going to equal 4/3 or 1 1/3. So the solution to this problem is the point 3 and 1 1/3. Okay. There you go. Now, it's not always going to be that simple. Let's take a look at problem 2 here. I've got the 3x's in both problems, except one's positive. Wait, they're both positive. Well, what I can do is go ahead and multiply through. I can go ahead and multiply through by a -1, because if I multiply through by a -1 on the one equation, won't that change the sign of one of the 3x's? So I'm going to multiply by a -1 here, multiply by a -1 there. So now my top equation remains 3x plus 5y equals 7. But after I multiply by -3 on the bottom equation, I get a -3x minus 4y equals -5. And again, it looks like it's easier, just be careful. Those will cancel. I add together and get y equals 2. Now to figure out x, I'm going to take one of these first two equations, substitute y in. So I think I'll take the top one, 3x plus 5 times 2. That'll equal 7. 3x plus 10 equals 7. Minus 10 minus 10. All right, give myself a little more room to show my work. 3x is going to equal -3. Divide by 3, divide by 3. X is going to equal -1. So we're going to have the point -1, positive 2. There you go. Okay, now, sometimes the coefficients don't match, like in problem 3 here. Well, if I could multiply by a -1, I could multiply by a different number. So I think on this problem, I'm going to try to get rid of my x's, and I'm going to multiply through by a -2. I'm going to multiply the 5 by a -2. I got to do it to one side and the other. My top equation remains unchanged for the moment. 2x plus 4y equals 8. I'm going to distribute and get a -2x minus 2y. That's going to equal -10. I'm going to add the equations together. X's will cancel. I'll have 2y equals -2. Divide by -2, divide by -2. X is going to equal -1. To find y, I'm going to take this second equation here, and I'm going to put -1 in for x. So -1 plus y equals 5. Add 1 to each side. Y is going to equal 6. So these will cross at -1, 6. Now some of you might be going, hey, this is way easier. You always get pretty answers. No, it's just the problems that I picked. Just the problems that I picked. They can come out just as strange as substitution or graphing. All right. Now, in many cases, none of the coefficients will match, or they won't be multiples of each other. So I can't just multiply by a 2 in the bottom equation. What I can do is multiply both equations. So for example, let's say I want to get rid of the y's on this one. Well, I'm going to think of the smallest number that 4 and 5 both go into evenly. If I count by 5s kind of off to the side here, let's see, 5, 4 doesn't go into 5, 10, 4 doesn't go into 10 evenly, 15, no, 20. Oh, 5 goes into 20, 4 goes into 20. So what I'm going to do is I'm going to multiply this equation by 5 because it will turn this into a 20. I'm going to multiply by 5 over here. But the bottom equation, I'm going to multiply by 4 because it'll turn the coefficient on y into 20 as well. All right. So the top equation is going to become 15x minus 20y, and that's going to equal 5. The bottom equation is going to be negative 8x plus 20y, and that'll equal 0. And notice I have matching coefficients that are inverses of each other, additive inverses. So I'll combine. Those are going to cancel. On the right-hand side, I'm going to get 5. On the left-hand side, I'm going to have 7x. I'm going to divide by 7, and x is going to equal 5 sevenths. I think I'm going to use this equation here because it's a little bit simpler. And so I'm going to do -2 times 5 over 7 plus 5y equals 0. I'm going to multiply and get -10 sevenths plus 5y equals 0. I'm going to add 10 sevenths to both sides. And I'm going to get 5y equals 10 sevenths. Divide by 5. Divide by 5, which is the same as multiplying by 1/5. Those will cancel. That'll go in once, go in there twice. And so y is going to equal 2 sevenths. So these two lines cross where an x-coordinate is 5 sevenths and the y-coordinate is 2 sevenths. So you see you can get some strange answers. All right, now again, hopefully you've been taking notes and trying to do the problems. If not, I suggest doing it again because when you come in tomorrow, it'll be so much easier for you. All right, Mr. Lawrence signing off. Good night, everybody.